Structural development of modern architecture. As the 20th century began, many architects believed it was necessary to invent a type of architecture that expressed the spirits of a new age and would surpass the styles, materials, and technologies of early architecture. This ushered in the age of modern architecture, which normally refers to the buildings and building practices of the late 19th and 20th centuries. Developments in iron and concrete formed the technological basis for much modern architecture. In 1779, English architect Thomas Pynchard designed the first structure built entirely of cast iron. Iron Bridge, a bridge over the River Severn in England. At around the same time, another Englishman experimented with a compound of lime, clay, sand, and iron slag to produce concrete. Iron had been used since antiquity to tie building elements together, but after the erection of Iron Bridge, it took on a new role as a primary structural material. One of the most spectacular examples of early iron construction was the Crystal Palace in London, England, designed by English architect Joseph Paxton to house the Great Exhibition in 1851. Spreading over 7.3 hectares, 18 acres, the building consisted entirely of panels of glass set within iron frames. Paxton adapted two major features of the Industrial Revolution for the architecture of the Crystal Palace: mass production in the manufactured glass panels and iron frames, and the use of iron rather than traditional masonry, stones, or brick. He managed to erect this vast building in less than 6 months, a feat he accomplished by detailed planning and by prefabrication of the building parts off-site. Steel for construction also became abundantly available in the 19th century. Improvements in concrete ran parallel to developments in iron and steel technology. In 1892, French engineer Francois Hennebequet combined the strengths of both in a new system of construction based on concrete reinforced with steel. His invention made possible what was previously unimaginable: extremely thin walls with large areas of glass, roofs that cantilever, project out from their supports to previously impossible distances, enormous spans without supporting columns or beam, and corners formed of glass rather than stone, brick, or wood. One of the earliest architects to experiment with these new effects was Belgian architect-engineer Auguste Perret, whose 1903 apartment building on Rue Franklin in Paris, France, exemplified basic principles of steel reinforcement. On the facade, Perret clearly separated the structural elements of steel-reinforced concrete from the exterior walls, which were simply decorated panels or windows rather than structural necessities. The reinforced concrete structure also eliminated the need for interior walls to support any weight, permitting a floor plan of unprecedented openness. Perret's building stood 8 stories high, with 2 additional stories set back from the front of the building, the typical height of most Paris buildings at the time. The construction of buildings taller than Perret's was made possible by the safety elevator and other architectural improvements. Architects in Chicago were the first to exploit the possibilities offered by the elevator in combination with the new steel and concrete technologies. And following a disastrous fire in 1871, architect William Le Baron Jenny devised a solution to the problem of fireproof construction for tall buildings by substituting steel in the structural system for cast iron, which melts at high temperatures. He continued to clad the building's exterior with traditional masonry, however. Architect Daniel H. Burnham and Charles B. Atwood took Jenny's system, yet stripped away the ornamentation characteristics of most buildings at that time, and instead used tall windows to emphasize the beauty of the building's skyward thrust. Most importantly, they eliminated Jenny's heavy masonry exterior, creating a system known as curtain wall construction. In this system, the exterior wall of each floor is hung on the iron or steel frame so that the wall supports only its own weight and not the floors above it. This method of construction reduced the overall weight of a building, which allowed it to be built higher, and permitted the extensive use of glass on the facade. The glass and steel skyscrapers erected through most of the 20th century drew much of their aesthetic as well as technological inspiration from the clean lines and light appearances of late 19th century Chicago buildings such as this one.